Hello, Keith Rucker here at VintageMachinery.org. Guys, today I'm going to do a little quick, easy video. This is I'm actually filming this on Christmas Eve 2024. This video I think goes live on Christmas morning. And honestly, just kind of taking it easy today, not doing a whole lot. And I got a little project, this is a fairly quick project that I'm going to try to get knocked out. This is something that the viewer asked me if I could help him out with. So this is something that came from Mike Malott. Mike is up in Ohio. If I remember right, Mike used to work for Cincinnati Millicron, who of course makes Cincinnati milling machines and other machine tools as well. And he actually is working on a metal shaper made by the Cincinnati Shaper Company, which is part of Cincinnati Millicron. And he was needing a part, and he actually machined the part. This is a spring washer that goes on the down feed head, I believe, that basically just kind of captures it in the back. He sent me a little diagram I'll show you here in just a minute of where it goes. In fact, I'll just put it in the screen here so you can see it, but kind of show you where it is. But basically, this is just made out of some 4140 steel. And like I said, he had the blueprints for this. He made it to the blueprints, but it does need to be heat treated. And there's actually heat treating instructions on the blueprints, at least partial heat treating instructions. It says that make it out of 4140 to austinize it at 1550 degrees Fahrenheit. Austinize basically just means to heat it up, quench it at that temperature, and at that temperature, this part will no longer be magnetic. When doing heat treating, that's kind of a key point. Whenever you lose the magnetism, that tells you you've reached that temperature where you can actually change the temper of it. Once we do a soak there at 1550 degrees, we're going to quench it in oil, and then it needs to be tempered to 53 Rockwell Hardness, RC, Rockwell C hardness scale. And actually, he said, according to some other documentation, it needs to be between 50 and 53, according to some other information that he has as well. So we actually looked up some information for a temperature to do the temper at, to get it in that ballpark, hopefully, and we're going to give it a shot here. So to do this job, once again, going to be working using my hot shot oven here, made by Hot Shot Oven and Kiln. I've talked about these before. I've had this for a while. Don't get to use it a whole terribly lot, but man, when it comes in time to need it, it really comes in handy. This is made, again, by Hot Shot Oven and Kiln. They're a sister company to American Rotary, which of course sponsors my channel. American Rotary makes three-phase converters. If you're in the market for a heat treat oven, there is a discount code that has Vintage10. I'll put a little thing right down here. There's also down in my description, there's information on this, but you can get a 10% discount when you're ordering either Hot Shot ovens or American Rotary phase converters by using that. And it also helps out my channel a little bit as well, because they give me a little bit of a commission whenever something's sold using that checkout code. But anyway, we're going to be using the Hot Shot oven today to do this. And basically, we're just going to put this in here, heat it up to that 1550 degrees, and go through the process of doing a heat treatment. So let's get this oven set up and get this part set up to do that heat treat. So before we do the actual heat treat, let me show the part here. This is, again, the little blueprint that he sent along that shows the part, and he's already machined it out to spec and everything else. Again, it's made out of 4140, and the instruction here says to heat it up to 1550 degrees Fahrenheit, do an oil quench. So that's what we're going to do. There you go. And I said I was going to inset it, but basically here's where this goes in the shaper head. This is on a shaper power down feed on the front. This is the clapper box, and basically there's a little assembly here where that swivels on. There's a spring in here, and that part in the yellow is that washer that basically goes on the back. He said whenever we're doing this that if it warps or anything, I can take it over to my surface grinder and just kind of clean the surface up and kind of get it back flat again. We'll take a look at that when we get through. Hopefully we won't have any warpage on it from the heat treat. So I think what I'm going to do is I'm going to actually wrap this up in some foil. This is some stainless steel foil for doing heat treating. And the idea here is you seal it up in this foil, and you're basically you're taking any oxygen away from this, and you keep it from oxidizing while you're doing the heat treating so you don't get any scale on it. So what I typically do when I'm doing this is I will put a little strip of paper in here, and that will give something that will burn up as heats up. So any oxygen that's trapped inside of the foil will be consumed when it burns up the paper in there, and then basically it's used up all the oxygen inside, and you won't have any oxidation going on. So let's go. I'm gonna give you a pair of shears here. We'll seal up a little foil pouch, and we're ready to put this in the oven. I'm just going to cut off a little piece here. Here we go. Just take a little piece of paper. We'll put that in there. Let's see here. We're going to fold this up kind of like such. And I'll just kind of fold up the edges. Do a couple of crimps on there. That's usually enough to kind of keep out any air from getting in there. And then we'll do the top here. All right, that is ready to go into the oven. So I'm just going to take a little piece of angle iron here and put it inside the oven. I've used that for this purpose before, and we're just going to set this little foil pouch in here. Tell you what, I think I'm going to do it on its side so I can pull it out a little bit easier. So we'll just do it kind of like that. And I'm setting it up on its edge just so that it gets heated a little more evenly while we're heating it up. And that way it's not laying down on something that's got some insulation to it, just getting more even heat all around it. And with that, I think we're ready to start heating it up. I'm going to turn on my hot shot oven here. Let her fire up here. And what I want to do is you can program this controller to do, bring it up to a certain temperature, hold it for a certain time, bring it up over a certain amount of time. And a lot of your materials that you heat treat require that. Now, I may be wrong on this, but the information that I found on 4140, it says basically just heat it up to 1550 and let it soak for, at least 30 minutes per inch of thickness. So I don't see any ramp up program that I need to do. So we're just going to manually do this. I'm just going to run my temperature. I'm going to go down here, and this bottom temperature is our target temperature that we're going for, and I'm just going to run that up to 1550. That's in the green. You see it going up. And once we get to 1550, we'll just stop right there. Let's see. 1550. I got to go up 50 more. There we go, 1550. So again, no ramp up time or anything like that. Just basically get it heated up to that temperature. It's only, 3/16 of an inch thick. So once we get it to temperature, I'm just gonna let it soak for 30 minutes. It should give that plenty of time to get completely through, and I go from there. So I'm going to enable my heat. I'm gonna go into my program button. Do we want to run a program? There's a program in here. No, I don't want to run it. We're just running this manual. So I'm just going to say no. I'm going to say run. Yes. I click the up button, say yes. I hit run. And now it's just going to ramp it up to 1550 degrees. So enable my heat, and we should start seeing the top number climb. The top number is the actual temperature inside the oven. The bottom number is the number that we're going to, so it is obviously heating up, and I'm just going to kind of keep an eye on this, and it shouldn't take it very long to ramp up to 1550 degrees. Once it gets to 1550, we'll let it soak for about 30 minutes, and then we'll do our quench. So we'll just let that run itself on up. Like I said, it shouldn't take long, and if I wanted to, I could say, okay, I want to heat it up slowly. You can do a ramp up, like where you say, I want it to take it to 500, from whatever temperature it's at to 500 degrees over the period of an hour, and it'll slowly ramp it up. And you can hold it at that temperature for a while, then slowly ramp it up to your next target. Again, in this case, we're just taking it up to the temperature. Fairly simple heat treat recipe. All right, we'll let it run up. All right, we've reached 1550, and this oven will keep it hovering right there around 1550 on its own. It's got a thermometer inside of the oven, and it's connected to the computer, the controller there. And like I said, it's going to keep it right there, right around 1550, within a couple of degrees above or below. And we're just going to let this thing roll. Let it go for about 30, 45 minutes, and we'll come back here and do our quench. Well, guys, this has been soaking in here for about 35, 40 minutes now. And I think we're ready. I'm going to go ahead and disable my heat. That's just going to turn the coils off inside of there. I'm going to go ahead and pull this out. I'm going to lay it on a little fire brick here to kind of see if I can get this thing to cut open real quick. I want to do this quickly as possible so we don't get it to cool down too much. All right, and lift it up. I've got some oil here that we're going to quench this in, and we're just going to put it down in here and cool it down. .4140 does quench in oil. Different materials need to be quenched in different things to get the cooling rate correct. 4140 uses oil. And I probably should have brought me a paper towel or something over here to set this on. We'll just set it down here. And I'll grab something to dry it off with. I've got my oil in a can with a lid where if it does flash over, I can just put the lid on to cool it or to snuff the fire out. And we'll just cool that or dry that off. And I'm going to let my oven cool down as well, because the next step is going to be to temper this. And to do that, I'm just going to let things cool off here for a couple of minutes, because we're going to need to drop the temperature inside the oven down. So let's just give it a little chance to normalize, and we'll be back. Yeah, it's cool enough to touch. All right, we let our oven cool down 245 degrees. Right now is what it's reading. So the next step after doing the hardening, this part is super, super hard right now. And the problem with being super hard is it also can become very brittle. And what you typically want to do is, after you harden a piece of steel, is you want to temper it back, make it a little bit softer, and get it to the hardness that you're looking for. I don't know, and I haven't tested. I could go over there and do it and see what the hardness is right now. It's probably around Rockwell 45 or so. It's just a guess. We need to soften it up just a little bit. Not too much, but just a little bit. And the way you do that, again, is you heat it back up, but at a much lower temperature. The lower the temperature you heat it, the harder it remains. If you heat it up to, we're going to do 450 degrees. If we went up to, say, 800 degrees, it would actually make it softer. But we're just going to heat it up to that temperature, let it get to that temperature, then we'll just let it cool down slowly on its own. After that, we're not going to quench it or anything like that. We'll just leave it out in the open air and let it cool it back down. And that should soften it up just enough to hopefully hit the mark. And I'm basing my temperatures just off of some information that I've been able to dig up off the internet and so forth. And hopefully we're going to be able to hit our numbers just fine. So I've got my oven set to 450. We're going to put our part back in here. I'm not going to worry about wrapping it this time. We'll put it on there. I'm going to enable my heat. And yeah, it's warming up. So it should take it up to 450 degrees. Once again, I'm gonna let it sit for about 30 minutes. Let it soak pretty good, and then we'll just take it out and let it cool down, and we'll see where we're at on the hardness. All right, here we are again. It's been about 30 minutes at 450 degrees. I'm gonna disable my heat, pull the part out, and I'm just gonna set it on this fire brick here, which will insulate it from below, and we're just gonna let that cool down naturally by air. I'm gonna turn my oven off, let it cool down, and we'll be back in a little bit after this cools down, and we'll clean it up and check its hardness, see where we ended up at. And we have let this thing cool down. It's warm, but it's pretty much at room temperature. So I think what's next is I want to get my hardness tester over here and see if we can get an idea of how hard this is. So let me go grab that and we'll do it. And to check this with, I'm going to use my PTC Instruments Model 316 steel hardness tester. This is a pretty interesting little hardness testing rig. It's not as accurate as a typical Rockwell tester, but it gets you in the ballpark. It gets you kind of where you need to be. And basically, you got a little automatic center punch that you just go here and you punch a hole in there, and you've got this little tool here that is basically kind of a light that goes down. You got a microscope looking thing that you look down through, and when you look down through there, you can see that dimple that is put in there by this calibrated center punch, and you look through the microscope and you read off the scale here depending on the size of that hole. It kind of gives you an idea of the hardness, and it'll get you to within, you can, it's got a line for every 5 points on the C Rockwell scale, and you can kind of estimate in between. So again, it's going to get you close. It's not as accurate as a regular tester, but it's going to be good enough for what we're doing here. So let me just do this real quick. I'm just going to check the hardness kind of in this center section because that's not going to be touching anything. So there's a dimple in there. It's not going to hurt anything. And I'm just going to take my little spring-loaded center punch, and we'll just bump it. And there's now a little dot right there. And I'm going to take my little microscope, make sure my light's still good. I may have to put some new batteries in this. Let me go put batteries in it. Well, my little barrel that holds my flashlight, the batteries have corroded in there and I can't get them out. I do have another little light here that fits down in there, and it is projecting light down. It's a little bit high. I'm hoping I can kind of look down through here and see what's going on. I think I can. Let me find my little dimple. All right, I'm sitting here looking at it, and according to this, it looks like it's between 50 and 55, and I'm just going to guess about 53 is kind of where I'm just guessing it's at. And let me go back and look at my specs and see where he wanted it at. I think that's actually where he wanted it. And yeah, 53 Rockwell. So I think we're right where we need to be on the hardness. The next thing I need to do is kind of see how flat this is, see if it warped at all while we were doing the heat treating, and if needed, go dust it on the surface grinder. And I think what I'm going to do is just take a precision ground flat stone and rub it on there, and that should tell me real quickly. I can see the pattern on it, see how flat it is. So let's check it out. Got my precision ground flat stones here, just kind of rub them together to make sure they're good and ready. And we're going to take our washer, and I'm just going to kind of rub it on here. And the theory is that that'll shine up the parts on there that are running flat. I'm just kind of spinning it around while I do that. So let's take a look here. Oh yeah, let me zoom you in a little bit closer and hopefully you can see that. So hopefully you can see there's just a little bit of shininess all the way around the inner and outer part of that, but it's uniform all the way around. So that tells me that's flat. It is touching a little bit higher on the edges. There's probably just a little bit of a burr there, but what's important is that it's flat all the way around. So I think this is flat. I don't think we got any warpage or anything, so I think we're just gonna send it on back like it is. Well, there you go, some light duty shop work on this Christmas Eve out here in the shop. Just want to get out here and mess around a little bit and get something checked off the list and get done. So a little quick and easy project. Hope you guys enjoyed seeing this heat treating process. And like I said, we'll get this sent back over to Mike, and hopefully he can get it back on his machine and back up and running. So with that, guys, we're going to sign off. As always, thanks for watching. Please subscribe to the channel if you haven't already. Those thumbs up and comments are always greatly appreciated. Subscribe if you haven't already. Hit that bell icon. Get notifications when new videos are posted. Hit that like button. Really helps out a bunch. Big, huge thank you to those who support the site financially through Patreon and PayPal. There's links for that down below if you want to be able to help out there. It really does help out a lot. And with that, we're going to get out of here. Wish everybody a very Merry Christmas if you're watching this at Christmas time. And with that, we'll catch you on the next video. Again, as always, thanks for watching.